Good morning. Myself, Dr. Maheswara Rao, Department of Civil Engineering, Institute of Aeronautical Engineering. So our course name is Fluid Mechanics, and today's topic is single column manometer. So what is this single? Single means one, and column means vertical. Okay. So manometer. So what is this manometer means? So here in this we'll have some fluid. This single column manometer, it is connected to any pipe. So where for which the pressure is to be measured. So what is the pressure existing in this pipe? What is the pressure of fluid inside the pipe? If you want to know that, so you have to attach this manometer. So single column manometer. So what will happen due to pressure of this fluid? This liquid may be hydrogen like that. So it goes down here and here it goes up. Okay, the difference of this is nothing but the pressure of the fluid in that particular pipe. So that we learn today. So before going to this topic, so we'll see the course outcomes. The course outcome is the student able to know all the definitions of the fluids and properties and what it is a surface tension and relations they can know. And course outcome is the Newton's law of viscosity and how the fluids are classified based on the Newton's law of viscosity, and also the problems, numerical problems related to the viscosity. That is course outcome 2. Then course outcome 3. So here it is a capillary rise or capillary fall. So what is that means? A small diameter pipe, whenever you insert into a fluid, that fluid will rise. Some of the fluids will rise in the small diameter pipe, which is called a capillary rise. And some of the fluids, the different fluids, if you insert a small diameter tube, so that the level of that fluid will fall down, will lower. That is called a capillary fall. So that is the course outcome 3. So, and the concept of surface tension, that means any fluid will have some tension at the surface of that fluid, which is called a surface tension. So the concept of the surface tension is the course outcome 4. And course outcome 5 is the compressibility. So compressibility means nothing but the change in volume. So if you take liquids and gases, so liquid, for example, water, so it is incompressible, the volume will not be changed due to the application of external pressure. But whereas gas, if you apply external pressure, the volume will be reduced. So there will be change in volume. So which is nothing but called here compressibility. Course outcome 6 is nothing but the pipe flow or fluid friction. That means whenever the fluid is traveling or flowing inside the pipe, so there will be friction between the two surfaces. One is inside surface of the pipe material and the fluid surface. So because of this movement of the fluid, there will be friction occurs. So due to that, frictional losses will be there. So as it travels or flows certain distance, the energy loss will occur due to the friction. So that will come under the course outcome 6. So fluid friction or pipe flow. So today's topic is a single column manometer. So you can see the figure here. So this is a single column manometer. So here it is a pipe in which gas is existing. So if you connect this, initially this liquid here, now it is showing the difference of 4 centimeters here. Okay. So before connecting to this pipe, gas pipe, okay, pressure of gas. So the level will be in the same. That means, so this pipe will be like this. The inside material, inside fluid. So normally it will be mercury. So mercury will be there inside the manometer, so which is having same level. So whenever you connect to the pipe in which fluid is there, then because of the fluid pressure, it goes down here, it goes up here. Okay, so if you see this, so manometers are devices used for measuring fluid pressure. So what is the use of this manometer? Nothing but you can measure the pressure of the fluid which is inside that particular pipe. Okay, so it is a fundamental to this fluid mechanics. So it is very important device, so that our tool by which you can measure the pressure of the fluid inside any pipe or any device. So how these manometers operate means the principle of hydrostatic equilibrium. So here hydrostatic equilibrium, static. Hydro means water and static means rest, at rest. So that means if the fluid is not flowing, whenever it is rest, so it will have an equilibrium condition. So that is the principle of manometer. So that is that the pressure is same in all directions. So if you take any point, the pressure in all directions, whenever the fluid is at rest, the pressure will be same in all the directions. So the principle of manometer is hydrostatic equilibrium. And you can see here, the single column manometer is one of the simplest forms. So it is very simple, very small tube, which is having some liquid inside it, some fluid. So it is very simple manometer. So this is commonly used to measure the relatively low pressures. So this is also called open tube manometer. Single column manometer, and it is also called open tube because this end is open and one end is connected to the pipe. Okay, that's why if the pressure is more, then what will happen? Inside fluid will come out. That's why this device will not be used for the higher pressures. So relatively low pressures only this open tube manometer or single column manometer is used. So here atmosphere pressure is there and gauge pressure is there. So if you take a tube like this, so inside mercury will be there. Okay, so this is mercury. So it will maintain same pressure because here is also atmospheric pressure, here is also a atmospheric pressure. So what is this atmospheric pressure? Whenever it is connected to pipe, then because of the fluid pressure, this here lowers and here it goes up. So because of the pressure of this. Okay, till what height it will goes, till it equals to the atmosphere pressure. Okay, initially how this atmosphere pressure is existing. So we can see so many gas molecules, so nitrogen, okay, water molecules. So like this, all these molecules move in the atmosphere. So whenever they are colliding, okay, collisions. So if these molecules while traveling, they collide, okay, what will happen? Kinetic energy is transferred. Okay, so whenever these are collide each other, so kinetic energy is transferred. So by that means air will have exerts pressure on its surroundings. Because of these collisions, air will produce pressure on its surroundings, all this area. So which is nothing but atmospheric pressure. So if you see the construction, so single column manometer construction. What is there in the construction is nothing but a single column manometer vertical glass tube. What is this? It is nothing but column. In the name itself, it is a column is there. So that's why it is vertical. So vertical means column. Glass tube. So what is this pipe material? This pipe is a glass. Okay, filled with a liquid. So it is a liquid. Okay, this is a liquid. So the pipe will have gas or water or something, any liquids, but this manometer will have other liquid, maybe mercury, depending upon the requirement. Okay, so this is a glass tube which is having liquid in it. That is the structure. So one end of this is open. Okay, what if we see figure here? The one end is open and other end is connected to pipe. Yeah, so one end of the tube is open to the atmosphere while the other end is connected to the system where the pressure is to be measured. So this is the system. That means it is a pipe. Okay, this U-tube is connected to the pipe so that we can get the pressure of the fluid inside that pipe. So you can see here, here is the liquid is rising. Here is because if it is initially without pressure like this, now it is rising here, it is lowering here, but here initially it is lowering and lowering. So why it is happening? Sometimes rising, sometimes falling. So if the pressure inside the pipe, if it is lower, then that means lower than the atmosphere pressure. So that means vacuum pressure. So what will happen? This will suck. That's why this liquid will go up. So if the fluid pressure inside the pipe is more, then what will happen? It pushes this liquid so that it goes down here, left limb, and goes up into the right limb. So depending, these two figures are, one is vacuum pressure or less than atmosphere pressure. Here another one is higher pressures. That means more than the atmosphere pressure. So here the H2, what is this? Is nothing but the left limb level and right limb level. The difference of this left limb level of the mercury or liquid and right limb level of the mercury or liquid. So that is called H2 here. And one more thing, the pipe center to left limb level is called H1 here. Okay, so H1 is pipe center to left limb level, and H2 is the level difference of the liquids in both left limb and right limb. Okay, so here atmosphere pressure will act as usual. So if you see here is also same thing in this figure. Okay, left side figure. So in this figure, pressure inside the pipe is less compared to the outside. So that's why the liquid in the U-tube is rising here. So H1 as usual, nothing but it is measured from the center of the pipe to the left limb level. Okay. Then H2 is also as usual. So it is a difference of levels of left limb and right limb liquid or mercury. Okay. So that is H. So our denotions are the same, but it is the matter of rising in the left limb and it is matter of falling in the left limb of that mercury. See, construction of single column structure. So here the tube either can be straight or slightly inclined. So it need not be straight always. Vertical means here also inclined. So here in this figure you can observe this is vertical. This U-tube is a vertical condition. Sometimes it can also be inclined. Okay. So it becomes like this, and slightly it can be like this. Okay. So it can be like this vertical or it can be inclined also. So this is straight or slightly inclined depending upon the precision required. So if we want more precision or requirement of the precision, this will be chosen as vertical or inclined. Okay. So here difference in height. So the difference in height means the difference of mercury levels in the left limb and right limb. You can see here in this figure it is 4 centimeter. For example, say that is nothing but the difference in pressures. Difference in pressures compared to the atmosphere pressure. So manometric fluid. So till now the manometer is having some liquid here. Okay, this is a manometer liquid. So what are the different types of manometers? Manometer liquids we are using and why it is used, in which conditions it will be used, we know. So here are the common fluids. So what is the common fluid? Water and mercury. So water can also be utilized as a manometer fluid, or mercury also can be utilized as a manometer fluid. In which conditions to be utilized? Mercury is having a highest density. So 13.6 is the specific gravity of that mercury. So that means 13,600 kg per meter cube. So if you take a 1 meter by 1 meter by 1 meter, 1 meter cube, okay. So then if you pour the mercury in that, it will weigh 13,600 kgs, so 13.6 tons, okay. So whereas water, it is nothing but 1,000 kg. So by means of this higher density and lower density, we can observe that if you can use to measure the lower pressures, if you want to measure the lower pressures, we can use the water. You can use the water as a fluid in a manometer. Or if the pressure is higher pressures are there in the pipes, then you cannot use this water because it can use only low pressures because it is low density. So mercury, whenever you want to measure the fluids at higher pressures, then mercury will be utilized so that you can observe the higher pressures. So mercury will be used as a fluid in the U-tube. So why it is used? Because because of its low density, its low pressure itself goes up. But whereas the mercury is having more density, and more weight, 13,600 kgs, 1 cubic meter. That means 13.6 tons, just 1 cubic meter. So if you apply any pressure, so it will rise only a little bit. So that's why very high pressures, there will be very less change in the level of the mercury in both left limb and right limb. That's why mercury is used as a manometer fluid whenever high pressure are to be measured. So you can see here different types of single column manometers. Here just it is having straight L shape. So if it is like that, then that is called a piezometer here. Okay, H is that. So then U-tube manometer, it is like this, U-tube. So I already discussed this. And also is having some rectangular box, tank below this. Okay. So this is single column manometer, and this is a U-tube manometer, and this is a piezometer. So these are the different types of manometer. So working principle of single column manometer. So nothing but the hydrostatic equilibrium. Okay. So you can measure the pressure at any point in a fluid at rest. Nothing but the weight of the fluid column above that point. So that means if you put this pipe, okay. So if any fluid is like this, if you want to know the pressure here, so this height, okay, this weight of this fluid above this point. So from this point, how much height is there? That weight of that fluid is nothing but the pressure at any point. So pressure at any, if you want to know the pressure here, so this weight of this much, okay, fluid on that column. So then if you want to measure the pressure at this point, there is no height, so that pressure will be 0. That means here at the top surface of that fluid, the pressure is 0. So working principle, how this is working. So single column manometer, how this pressure is measured. So what he is telling here, when connected to a system, so that means this U-tube or single column manometer connected to a system. System means it may be pipe. Okay. So in this pipe, fluid may be there and liquid will be there. Okay. So when connected to a system, the pressure from the fluid in the system forces the manometric fluid goes up. Okay. So because of initially this level, mercury level will be like this. So okay, whenever it is connected to a system like pipes, so because of the pressure existing in the pipes, so what will happen? This manometer fluid goes down here. Initially, this is the level, so here goes up. Okay. Now this is the position of the manometer liquid because of the forces applied by means of the fluids which is present in the pipe or device or system. Okay. So that's why it is going down. So if it is going up, also sometimes occurs because this vacuum pressure maybe exists in the pipe or device. Okay. The height of the fluid column H is directly related to the pressure difference. Okay. So whatever the difference of this H, both the links H, it is nothing but the pressure difference of that between the here pressure difference. The difference, when can you use the difference word? So if you have two things, then you can say it is a pressure difference. So what are this? One is pipe. Okay, pipe, it is connected to the pipe. So one is the pressure existing inside the pipe. What is the other one? So here YouTube. So here will be atmospheric pressure. Okay. So because of this atmospheric pressure, the difference. So the YouTube manometer or single column manometer will give the pressure difference, not the pressure inside the pipe. Exactly, if you want to say, it is nothing but the pressure difference between the inside of the fluid pressure and outside pressure. Outside pressure is nothing but atmospheric pressure. The difference it is giving, there is nothing but the difference of level in left limb and right limb. So there is a formula is also there. You can see here. Okay. So the pressure difference delta P. So you can get using the formula delta P is equal to rho GH. So this is the formula. So if you want to know the pressure, you can apply this formula. Whereas rho is equal to density of the manometric fluid. So what is the manometric fluid? The pipe is here and manometer is here, and manometer fluid will be here. So here this is density. Here also density will be there. It is fluid which is present in the pipe. But here in the formula it is utilized rho of the manometric fluid, which is a mercury normally. Okay. So rho is the density of the mercury or manometric fluid. So then G is the acceleration due to gravity. H is the height of the fluid column. Height of the fluid column or difference of elevations of manometric fluids. So here gauge pressure and absolute pressures. Two things are there. Okay. So what is the gauge pressure? What is the absolute pressure? So you will know it. Okay. So a single column it measures gauge pressure. So till now we discussed the delta P is equal to rho GH by using of manometer. So it gives the gauge pressure. Okay. It is not giving the atmospheric pressure. Okay. So gauge pressure, which pressure is relative to the atmospheric pressure. So it is related to the atmospheric pressure. So then if you add this atmospheric pressure, okay, to the gauge pressure. So whatever the manometric pressure, and if you add the atmospheric pressure, then you will get the absolute pressure. So absolute pressure is nothing but the summation of the gauge pressure and atmospheric pressure. So here gauge pressure means YouTube, this H is the difference, rho GH if you get, this is called gauge pressure. Okay. Then if you add to this atmospheric pressure, then it leads to the absolute pressure. So you can solve one small problem. So here manometric fluid density is 13,600 kg per meter cube. That means here pipe is here, here tube is given. So what is the fluid here? It is rho is equal to 13,600 kg per meter cube. And the acceleration due to gravity is 9.81. Height of the fluid column is 0.3 meters. Okay. So here it will be like this. So this is the difference of height of the fluid column. So the formula is delta P is equal to rho GH, where rho is the 13,600 and acceleration due to gravity is 9.81 meter per second square, and height of the difference of this manometric fluid levels, so that is 0.3. Then if you multiply this, you will get the 40,017 pascals. So what is the pascal here? It is nothing but the Newton per meter square. The pressure difference measured in the manometer is 40,000 pascals. Also, if you divide by 1000, so that means it will become 40 kilo pascals. So, and if you review what we learned today, so today we discussed the single column manometer. Okay, it is why it is why you should means if you want to measure the fluid pressure, then we have to use this tool. So that's why it is a very fundamental tool in the fluid mechanics. And the working principle of this manometer is nothing but the hydrostatic equilibrium. So that means the pressure is same in all the directions whenever the fluid is at rest, not at a moving time. And this is the simplest form. So can you easily measure the difference? Okay. And it is also called the open tube manometer because one end is open of the U-tube and another end is connected to the system. And how this atmospheric pressure is existing means because of this gas molecules in the atmosphere, they are moving, and whenever they move, they collide each other. So whenever they collide, the kinetic energy is transferred during collisions. Okay, so that's why air will exert pressure on its surroundings. That is called nothing but the atmospheric pressure. And the construction of the single column manometer is nothing but it is a glass tube. Okay, it is a vertical glass tube and filled with a fluid. Okay, so it is also called one end is open. That's why it is a open end manometer. So one end is open to the atmosphere and another end is connected to the pressure device or pipe. So here in this figure, first figure, left side figure, the fluid manometer fluid is rising because low pressures are existing in the pipe. In the second right side figure, you can see this. Okay, the fluid is falling here, so it is pressing pressure. So why it is happening means because the high pressures are there in the pipe. That's why left limb fluid is going down and right limb is rising up. So single column manometer means it is not only straight, sometimes it also can be slightly inclined like this figure. So depending upon the precision required. Okay, so difference in height, that means difference of this manometer fluid levels. Height is nothing but the difference in the pressures. So pressure differences. What is the pressure difference means? The pressure inside the pipe, pressure of the fluid inside the pipe, and atmospheric pressure difference. And manometric fluids. So here some common manometric fluids are there. So water and mercury is usually as a common manometric fluids. So what is used for low pressures because of its low density, whereas the mercury is utilized to measure the high pressures. So mercury is utilized as a fluid, manometer fluid. So in order to measure the high pressures because of its high density. So here piezometer is there and the U-tube manometer is there and single column manometer with a tank is there. So hydrostatic equilibrium means it is nothing but the pressure at any point is nothing but the weight of the fluid column above that point. And working principle, whenever you connected that U-tube to a pipe, so that the forces will be applied in the manometer fluids. Okay, because the fluid will come inside of a manometer and pushes this fluid, mercury or water it may be. So pushes. Because of that force, the manometer fluid will fall in the left limb and rise in the right limb. The difference of the levels of the manometer fluid is nothing but the pressure difference. Okay, this is nothing but pressure inside the pipe. It is also a difference of atmospheric pressure and fluid pressure in the pipe. There is a formula to calculate the pressure difference. Okay, the pressure difference here it is delta P. So whereas h small h is nothing but the difference of levels of the manometric fluid in left limb and right limb, and rho is the density of the fluid, manometric fluid, and g the acceleration due to gravity. So here gauge pressure and absolute pressure is there. So gauge pressure means this U-tube manometer, you are getting the gauge pressure. Okay. So absolute pressure means if we add this gauge pressure plus atmospheric pressure, then it will be absolute pressure. So why it is so means, so gauge pressure means here the fluid will exert pressure, here also atmospheric pressure will act. Okay, so that's why this pipe YouTube is giving the gauge pressure. So this is extra pressure is there on the right limb because it's open to the atmosphere. So if we add this atmosphere to this gauge pressure, then you will get the absolute. So it is an example. Manometer fluid, here it is a mercury is given, density rho is the 13,600 kg per meter cube, and height of the fluid curve, that means the difference of levels of the fluid, manometric fluid, left limb and right limb is 1.3 meters, acceleration due to gravity is constant for air 9.81 meters per second square. So pressure difference is equal to rho gh as per this formula. So rho is 13,600 kg per meter cube, g is the acceleration due to gravity 9.81 meters per second square, and height of the fluid column is the 0.3 meters. So if you multiply, you will get the 40,000 pascals, or if you divide by 1000, you will get the 40 kilopascals. So the references are here: K. Subramaniam, 3 Applications of Fluid Mechanics, Tata McGraw-Hill's 2012, and another book is, another reference is Modi, PN, and SM Seth, Hydraulics and Fluid Mechanics, Standard Course 2002. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.